Good day, everybody. We have a signal generator here by Eico. It's a Model 324, made in 1954. Puts it at 70 years old. It's quite old. The wave pattern on it is not that great. Actually, when I first got it, one of the tubes didn't work at all, so I replaced the tube. But still, the wave pattern's not that great. You know, this thing has had someone in it at one time. You can see the drawing on here. Someone actually put a mica from here to where it's running to on the back side of it. So I think today we're going to pull it apart, clean it up, and replace the caps inside. So all the paper, all the electrolytic, and then some of the resistors. I checked them. There's at least 6, I think, that are past their values. So we're going to go ahead and change those out while we're in there, and then test it and see what kind of wave pattern we have. I'm hoping that there's no further issues from it. I need this one to work on some radios to align them. I have my other function generator, BK Precision. I don't like using it all that much on the radio alignment because I'm not sure if I'm doing it the right way. So when you look online on how to do it, or any other place you get your source from, a lot of people are using something like this. So I'm trying to just make it easy on myself and use the same thing. And plus, it's kind of cool. I mean, it's 70 years old. It's vacuum tube, and it's amazing that these things still work. So give it a new lease on life, freshen it up, and hopefully everything works. Right off the bat, you can see that, you know, I can turn this right here. We got some slop in there. I think these things are held in with set screws. Hopefully it's not missing it. Everything else on it turns pretty good, but we'll go ahead and clean out the pots and contacts and anything else we can do to it. So it's not the cleanest model out there. You can see someone scribed on here DISD. I'm assuming this came out of a school. I'm not sure. Or maybe that doesn't even say. Maybe that's DISP. I don't know. But you turn it to the other side. There's a serial number on here to whoever owned it. When I did get it, it did have all the screws. I have all those to the side. So cord is a little bit of rush shape. I don't think I'm going to replace it right away, but I'll clean up the contacts on it, and then go from there. Biggest thing is I want to make sure that we're getting a good wave pattern out of it. So okay, all right, let me get the cover off, and we'll go from there. Alright, so we got the cover off of it. You can see it's pretty clean. Got our 2 tubes. This one is a 12A U7. This one is a 12. This one right here, 12A V7. And this is the one that was not working when I first got it. You can tell it's pretty clean. I believe these units are assembled by, maybe they came in a kit. I'm not real sure. I don't know if it's like the Heath kit or not, but it would explain a lot if someone got this at home as a kit and they put it together. You can see underneath this, it seems to be all original except for this guy right here. I think that is a mica. It could be a film. I haven't really looked at it. I may leave it in, I may pull it out, I don't know yet, but a bunch of these resistors are the carbon type, and they've gone past their tolerances, and not all of them, but a good chunk of them. So we'll go ahead and replace it, and then we're going to go ahead and replace all these films. Right? I don't have a good way to test them to let me know if they're good or bad, so I'm going to assume that they're bad, and then we have our electrolytic right there for the power, and it's a 20 UF times 2. Should be pretty easily to replace. I'll not use this clip right here. I probably won't pull that out, but I'll probably run it from the ground to wherever they're going to. So it does power up. Lights come on. Again, the the tubes do light up. I do feel like I'm not getting enough power to some of them. Maybe this guy. It gets a little warm, not a whole lot. And then the one thing that did catch me on this thing, caught my eye, was, let me zoom in there and see if I can get this to focus. This is not soldered. It's just, and the other side as well. So we'll fix that. It's probably just a innocent mistake, whoever put this together. But yeah, we'll go ahead and fix it. And then I'll clean out all the pots, and then on the tuner I'll spray it down and lube it up and see what we get. Hopefully it'll make a big difference. You never know. Sometimes I do this stuff and I don't see any difference, other than peace of mind that it's going to work. So okay, I think the first thing is we will replace the resistors first. So I went ahead and measured all of them, and on the ones that I need to replace, I took a ink pen out and I put a little mark on them. Right, I don't have a good memory, so if you can see that right there, I put a little spot on it, so I know that I need to pull that and replace it. This method works for me when I'm doing these, because what I end up doing is I get these in and I'll take all the measurements, make sure I have the parts on hand, and then I'll have to order them. And then when I get them in, get the parts in, I don't know, I don't remember which one I checked and which ones I didn't, and which ones need to be replaced and all that. So probably need to use a different color marker. Maybe someone might stake that as a 10% value on the back of it, but that's the whole point, is to get it removed. Alright, so end up replacing a lot more resistors than I expected. I think I replaced everything but 2. So, and these tight spots become very challenging, and but I got it done. Well, I'm not done yet. I'll show you in the bottom. No, I don't focus on that. Focus right there. No. No. Right there. So I replaced everything on the back side of this tube, except for this guy. He measured just fine, which is turned out to be pretty rare on this one. Everything was off, more than I expected, more than what I originally measured. So I end up replacing, let me get a little pointer. I end up replacing all these up here, and these are soldered in. And let me put this up. And I end up replacing everything down here. I have not soldered this in yet, because I'm going to have to, on the same terminal lugs, I'm going to have to replace all these guys. So I just left it unsoldered. Everything's just kind of hooked in, and that'll be the next step, is to start replacing all the capacitors. Hopefully that won't take me as long as this took me. It took me well over an hour or more to get it done. Biggest challenge I had was just getting everything fitted in the way it's supposed to be, and not breaking anything. So Yep. All right. So I'm gonna start replacing these capacitors, and when I'm done, I'll show you what I did. Yep. Okay, I got almost all the capacitors replaced. It was a lot more challenging than I expected. You know, the solder and all the resistors can't say I'm real happy about this. The placement of the electrolytics, not too happy with, but I can come back and put a 5-point terminal lug soldered in right there and make it a lot better. But for right now, it will work. So you can see I replaced over here, these guys, everything in here. Did we have anything up on top? Nope, we had nothing up on top. These little white capacitors, they normally do not go bad, so I'm not gonna even try. Let me see if I can zoom in there. There you go. I often confuse these with resistors, but I'm getting better at seeing them. But I did run into one problem. All right. Now that we got our capacitor out, we need to figure out what the foil side is on the new one. The new capacitors do not mark the foil side. They might have a black line already on them, but you can't trust it. You got a 50-50 chance of it being correct. There's a lot of ways to test these to see which side the foil side is. There's a lot of devices you can build to make it, but I find it the easiest for me to use an oscilloscope because I already have one here. Now, in fairness to all the other ways, I've not tried any of the other ways, so maybe one day I'll get around to building one of the devices on YouTube to test these. I'm just not there yet. So we'll get this started. Let it boot up, and we'll give it a try. So the idea here is that you have your probe and you have the negative lead here, and when you're going to clip it on each side, right? Probe on this side, negative on that side, and then you're going to flip it, and you're going to compare the waveform on the screen, and the lowest waveform, right, the smallest waveform, will be that ground side will be the foil side. Sometimes it can be a little hard to detect, and you have to do it a couple of times. One of the things is you have to hold the capacitor in your finger like that, and make sure that you do not touch the wire or the probes, right? And I found that you want to make sure that you're holding it consistently when you change the probes over, just so you have the same contact on there. And your body, the electricity in your body, filters onto this capacitor, from my understanding, and this is what you're picking up in the waveform. Okay. So we clip one on one side. It doesn't matter which side you do first. And you can see the waveform. Let's see if I can get a better picture of that. Sorry for it flickering. Hopefully that'll go away in editing. So we'll make sure that everything's on. I test these in 1x and the probe in 1 as well, just so I can get a straight through of what's going on. And I always, when I start this, I always align. See if I can get that cleaned up a little bit. Yeah. maybe we'll go to DC. It's like it doesn't matter. Okay. And you have to excuse all the static in here. There's something going on with my oscilloscope. I don't know what it is yet. But what you want to do is, right now we're about one sector, right? No, we're from that line to this line, and just keep that in your memory, right? So now we're gonna change it around. Now I'm not moving my fingers at all. That's holding on to the capacitor, and I'm just using the other hand to change it around. Now you can see that is slightly smaller, right? From top and bottom. Before we were filling out from one section to the next. So what it's telling me that the way it is right now, this is this is the side I need to mark. So we'll go ahead and mark it. Okay, I got it marked. And the reason why you don't want to touch the wires, let me back up a little bit. The reason why you don't want to touch the wires is watch the waveform in the back, right? If I start touching these, it will introduce a different signal into there, right? So, and another situation that I found out the hard way is that make sure you're wearing shoes when you're doing this test. I'm going to take this out of the screen, but I'm going to keep holding on to it because I want you to get a clear shot of the oscilloscope. Alright? Right now I have shoes on, and it is insulating me from the ground. As soon as I put 1 foot down, it discharges and you're not going to get any kind of signal. I didn't find this out till recently, and I had to stop filming yesterday because I was so frustrated trying to figure out why is it not working. And then it just dawned on me, right? So yeah, don't make the same mistake. See, my foot's still on the ground. I lift it up, boom, it's right back, right? Okay. All right, so now we got the foil side. Now we just need to get this soldered in real quick. Go ahead and turn that off. Back up the camera. And we'll get this started. Now, when you're laying this on this side, right, you need to be real careful because you're putting a lot of weight on here. You can use something to stand it off. I'm gonna just try my best not to make, well, maybe I need to do this. Get it off of the oscilloscope probe. Okay. Get it back in focus. So this guy is going to go from here to here. Something like that. I'm going to put a bit of heat shrink on each side. So let's get this back down. I'm going to just put a little bit on each side of the lead. Just like that. Right? Put my glasses back on. I can't see whatever I did with them. Okay. Alright. So this little guy, someone soldered this with it closed over, so I had a hard time getting it out last time. Let's try to get that focused in there. So I'm going to try to get this heated up just so I can get this slid inside like so. That's bottomed out. I'll cut the lead off and push it in some more. Okay. And then I'm going to take it up. And we're going to go up just like so. Get my heat shrink. Put it on there. Is that enough? No, too much. That's horrible. That is so out of focus. I'm going to go a little bit closer because right now it's focusing on the oscilloscope in the back. How about that? There we go. Alright, so that's how it's going to go. So I'm going to go ahead and cut part of that off. Alright, so that's in there. I really need to go back and solder the other side. So all I did was slide it into the little opening, and the solder that was in there did hold it in place, but I don't have a lot of faith that it's going to do what it's supposed to be doing. So see if I can get that to focus. There we go. All right. So if I did everything right on this guy, I do want to make sure I go back and clean up a little bit my leads. Some of these are pretty hideous. Okay. All right. So I think now we're going to put it back together, turn on the oscilloscope, and see if we can generate a halfway decent signal. Hopefully I don't have a tube problem. We will cross that path when we get there. So let me get this set up and we'll turn it on. They're hooked it up to the oscilloscope, and it looks like we are doing okay. Before it wouldn't make a pattern at all. We did have one bad tube. I think I said that at the beginning. We replaced that. And if we look at our frequency, where is it? Time. We're sitting at 3.96 megahertz, and we are showing we're on band D, and we are, so I can get that in there. We're pretty close to 4. All right, right here. So the next thing I will do is clean up the face. I've not cleaned out the pots yet. I will get those sprayed out and lubed up, and that's why I need to put the knob on here. And go from there. I don't even know where this is set at. Where are we set at? Oh, we're set on high. Okay. So let me get this cleaned up, and I'll spray out the pots, and then I'll come back and we'll hook it back up and just make sure I didn't break anything in the process. Okay, cleaned out the pots, gave it a light cleaning, hooked it up to the oscilloscope. Everything looked just fine, but I wanted to really check the accuracy of it. Right, you can see that we are on band C. On high, we're here. Turn that all the way down. We're gonna get up to 50. And if we look at where we're at, let's see if I can get this squared up. All right, let's say band C. We should be pretty close to 2. All right. So I hooked this up to my counter, and you can see that we are pretty close. So I think I will, I'll take that. And then if we go back and hook it up to, if I can get that shot right here, hook this up to the oscilloscope. Get the flickering to stop. You can see that we're okay. And you can see the frequency right here, right? Is pretty close. So I'm going to call this a success. I can't wait to use this in the work that I want to do with the radios and get the alignment done. I was using this guy to try to do the alignment. I think it's a little bit too much for me at this time to try to understand how to make it work properly. I'm just not there. So, and then last time I used it, I blew up the radio. I had the grounding wrong. So I'm a little jaded and a little scared to use it again. So I think something that was purpose built should be a lot better. So I can't wait. If you like this, give me a thumbs up, subscribe, leave me a comment. If you don't like this, hey, give me a thumbs up, subscribe, and leave me a comment. Good or bad. I appreciate it. Bye.